All right, let's look at the homework 2.8, problem number 9. All right, so we have a quadratic function given here, and we want to find the first derivative and also the second derivative. All right, so let's do that. All right, so first derivative, we can just use the definition. All right, so it's going to be a limit as h approaches 0. All right, then we have f of x plus h. So every time we see x, we're going to put the x plus h. So 3, and x now becomes x plus h squared minus 5 x plus h plus 2. Right? Minus f of x, which is the original function. So put the 3x squared plus 5x plus 2, and all over h. Right? So we can cancel at least 2 and minus 2. Alright, then I'm going to just multiply out and see if we can cancel more. So limit as h approaches 0. Alright, and we have 3 times. Alright, so you have x squared, so we're going to have to square that. X squared plus 2xh plus h squared. And then we're going to distribute 5 to, actually negative 5 to x and h. So you have minus 5x minus 5h. Right? Then we have a minus. Distribute the negative sign to both of these remaining terms. So we have 3x squared minus 5x. Right? So we have that. Right? Oh, actually, I messed that up here. This was actually a positive sign here. So these two are positive. Right? So we have that. All right, then we can do a little bit of a cancellation. Oh, I forgot h. All right. So we have, let's see. So you have a 3x squared minus 3x squared. So I'm going to just scratch those out. And then you have a 5x here minus 5x. Scratch those out. All right, so what's left is limit as h approaches 0. All right, so you have distribute the 3 to 2xh and also h squared. So we get 6xh plus 3h squared. And then we have a plus 5h, right? So we took care of all these guys, right? So this says the remaining guys and that, and took care of that. And then all over h, right? So luckily, all 3 terms on top, on the numerator, has h in it. So I'm going to factor h out. Right, if you pull h out, you have 6x left from the first term. Pull out, so you have a 3h, and pull that out, so you have a 5, and then over h. All right, then you can cancel h on top and h on the bottom, and h is going to 0. So this guy is going to go to 0. All right, so therefore, we get, let's see, 6x plus 5. Right? So first derivative is 6x plus 5. All right. Then we take another derivative. So if you want to find, I'm going to do it here, f double prime of x. So this is just simply the derivative of the derivative. So I'm going to take the derivative of 6x plus 5. All right. So you have a limit as h approaches 0. All right, so we put x plus h, so 6 times x plus h plus 5 minus 6x plus 5 and all over h. All right, so we can cancel. There's a 6x, and then you have a 6 minus 6x, 5 minus 5. All right, then what's left is you have a limit as h approaches 0. All right, you have a 6 times h, so 6h left over h, so we can cancel h's. All right, and the limit of 6 is going to be 6. All right, so the second derivative is 6. All right, so let's type it in. All right, we got 6x plus 5 and 6. All right, maybe I'll do all of them. All right, graph f and f prime and f double prime on a common screen to see if the answers are reasonable. All right, so I'm going to just open up GeoGebra here. All right, so f of x is equal to 3x squared plus 5x plus 2. Was it? Yep. So we have that. All right. So that's f of x. All right. F prime of x. Actually, you don't really have to. I'm going to just hit enter. It actually finds the derivative for us. And f double prime of x is going to be 6. So you can see that this is the original function, and here this is the first derivative, which is a straight line, linear function, and the second derivative is a constant function. All right. We see from the graph that our answers are reasonable because the graph of f is that of a linear function, right? Because it's a straight line. And then f prime is that of a constant function because it's just a number. All right. So let's check the answer. All right. I came back and it looks like we got this one correctly. All right. That's it. I hope that this was clear.